Hello everybody! Welcome to tonight's video. This one's going to be about adding and subtracting rational numbers, and this goes with the learning goal. I can add, subtract, multiply, and divide rational numbers. So we're just going to do the first half of that tonight. And basically when we're talking about adding and subtracting rational numbers, we're going to be talking about adding and subtracting fractions. So what do we do when we add and subtract fractions? There are two steps if we're just dealing with simple fractions. We write equivalent fractions that have the same denominator, and then we add or subtract the numerators and keep the denominator the same. So here's an example of what that would look like. We're going to write these two fractions so that they have the same denominator, and we're going to write that so that we have two fractions that are equivalent, but again with the same denominator. So we have to look at 2/15 and 1/10 and think about what is the least common multiple of those two numbers. What is the smallest number that both 15 and 10 can divide into evenly? Now, the smallest number that I can think of would be 30, so I'm going to use 30. It doesn't actually matter if it's the smallest, but it just makes everything easier to work with if you can find the smallest. I'm going to take each fraction, 2/15 and 1/10, and rewrite it so that they are in 30ths. And the way that we do that, remember, is to multiply the numerator and the denominator by the same number. 2/15, and think about, well, what do I have to multiply 15 by to get 30? I would need to multiply that by 2, and so I am going to also multiply the 2 times 2, and that way I get 4/30ths. And then looking at 1/10, I look at, well, what do I have to multiply 10 by to get 30? I would need to multiply it by 3. So I am also going to multiply the 1 by 3. And that way, I get an equivalent fraction of 3/30ths. So I'm going to be adding 4/30ths plus 3/30ths. Now my second step, I've done the first step, write equivalent fractions with the same denominator. So now I'm going to add my two numerators together and keep the denominator the same. So I'm going to add 4 plus 3 gives me 7, and I'm going to keep my denominator the same, so that would be 30. Okay, now we're going to do the same thing when we subtract. We're going to look for a common denominator and use the least common multiple of 10 and 4. And then we're going to change those two fractions so they have the same denominator. Pause the video now and try to do this subtraction problem on your own. Here's the problem you get once you've found a common denominator. So now we're going to think about subtracting those two. I'm going to be taking 1/10, which is 2/20ths, and subtracting 1/4, which is 5/20ths. So now I'm going to do my second step, which is to subtract the numerators and keep the denominator the same. So my denominator will be 20, and I'm going to do 2 minus 5. 2 minus 5 is the same thing as adding a negative, so I'm going to do 2 plus -5, which is -3/20ths. We're breaking adding and subtracting mixed numbers up into two steps, and there's actually two ways that we can add mixed numbers. So I will show you the first way. The first thing we're going to do when we're doing this first way is to change the mixed numbers to improper fractions. Then we're going to go through and do the same steps that we did for adding and subtracting fractions. And then we are going to either leave the sum as an improper fraction, sometimes that's the best thing to do, or change it back to a mixed number. I'm going to first change my mixed numbers to improper fractions. And the way that we do that is by multiply the denominator times the whole number, and then I am going to add the numerator. So you kind of go in a circle like this. First multiply, then add. So I'm going to do 5 times 4 is 20, plus 3 is 23, and my denominator doesn't change when I am changing to an improper fraction. So then do the same thing here. I'm going to do 4 times 2 is 8, plus 3 is 11/4. So now I again have to write equivalent fractions with the same denominator. So I'm going to change 23/5 and 11/4 so that they both have a denominator of 20, because 5 and 4 both divide evenly into 20. We're going to multiply both of these by 4, so that we would have 20 in our denominator. And then 23 times 4 is 92, so I have 92 twentieths. And then if I have 11 fourths, I need to multiply 4 times 5 to get 20, so I'm going to multiply 11 times 5, which is going to give me 55 twentieths. And now I just need to add those two together. I'm just going to do what the third step says, add the numerators and leave the denominators alone. So I will add 92 plus 55, which is going to give me 147, and I'm going to leave the denominator alone, which is 20. I could leave this as an improper fraction, or I can change it back to a mixed number. If I want to change it back to a mixed number, I have to ask myself, how many times does 20 go into 147? And I know that 2 goes into 14 7 times, so 20 times 7 is 140. So that would mean that I would have 7 left over, and I still keep my denominator of 20. So that would be 7 and 7 twentieths. There's a second way that we can add mixed numbers, and for this way, we're going to write equivalent fractions that have the same denominator. We're going to add the numerators and leave the denominators alone, and then we're going to add the whole numbers. So we are leaving these as mixed numbers. And then our last step is, if the fraction, at that point, the fraction part of it is an improper fraction, we're going to have to change that to a mixed number and add the two whole numbers. So what does that look like? So here, I am not going to change these to improper fractions. I'm going to leave the fraction part. So we would have 4 3/5, and again, I want to change this so that I have a common denominator. And again, I'm going to use 20 because I have 5 and 4. So 3/5, I would need to multiply 5 times 4 to get 20. So I also need to multiply the 3 times 4, and that will give me 12 twentieths. And then 3/4, I have to multiply both of these by 5, so that I'm going to get 20 in my denominator, and 3 times 5 is 15. So now what I'm going to do is I'm going to add the whole number parts, add 4 and 2, which gives me 6, and I'm going to add the fraction parts by adding the numerators. So 12 and 15 is 27 twentieths. However, 27 twentieths is an improper fraction, so I now need to change that. So I still have the 6. 27 twentieths is equal to 1 and 7 twentieths, because 20 goes into 27 one time with 7 left over. So now I have to add these two whole number parts together. So I'm going to add the 1 and the 6 and get 7, and then my fraction part is right here, 7 and 7 twentieths. You can use the same two different ways when you subtract mixed numbers, but I'm going to show you the way of changing your mixed numbers to improper fractions, because that way you don't have to borrow, and borrowing can cause confusion. So I'm recommending that you always change mixed numbers to improper fractions when you subtract, so that you don't have to worry about borrowing. So the steps we're going to follow are: change the mixed numbers to improper fractions, again write the fractions so that they have the same denominator, subtract the numerators, leaving the denominator alone, and then you can either leave your difference as an improper fraction or change it back to a mixed number. Here's our example. In 2000, a single storm dropped 20 3/10 inches of snow in North Carolina. The previous record was 17 4/5 inches in 1927. Write and solve an equation to find how much more snow fell in 2000 than in 1927. So since I'm going to write an equation, I'm going to start with 17 4/5. I'm going to add the increased amount, and that gives me my new record of 20 3/10 inches. So to solve this equation, I need to add the opposite of 17 4/5 to both sides of my equation so that I can isolate n. So this adds up to 0, leaving n over here. And like I said, we're going to change these two mixed numbers to improper fractions. So 20 times 10 is 200, so I get 203 when I add the 3/10, 89 fifths. My common denominator here is going to be 10, so I need to multiply both of these by 2. And 89 times 2 is 178. over 10. So now I'm doing 203 over 10 minus or plus a negative 178 over 10. So I get 25 tenths. So n equals 25 tenths. And I'm going to go ahead and rewrite that. A mixed number, 10 goes into 25 two times with 5 tenths left over. I can rewrite that as 2 and 1/2 because both of those numbers can be divided by 5. So the increase was 2.5 inches. And here are your free response and multiple choice questions. So go ahead and pause the video.